So this will take care of that, hopefully. So no song of the day today, no warm-up. It's Friday. It's 9:20. So, properties of equality. How is your Rice Krispie meal?
It's great.
Yeah? Interesting. I love that there's this like very wholesome cereal that's being held together by horse bones. Right?
Mm-hmm.
Yeah. All right, properties of equality, things that are true about equality. So when you have an equal sign and you don't have an unequal sign, an unequal sign would be like less than, greater than, stuff like that, right? These things are all true. We're going to run through them super duper quick because, again, words are hard, math is easy. Lainey, hi.
Horse dogs?
Gelatin. Like the stuff that's in Jell-O and in marshmallows? Yeah.
That's not horse bones?
Yeah.
No, it's not.
It's bones. Usually it's horse, but...
I've never eaten it again.
Well, I mean, now you know, right?
I am right.
Okay,
It's great horse bones. It tastes real good.
right. So if A equals B, meaning that if we have an equation, they give us an equation, right? We have a left side and a right side here. If they're both the same, because that's what an equation implies, right? Then we should be able to add the same number to both sides and it still be true, right? If I start out with 3 equals 3, it's all good. If I add a number to both sides like 5, then we have 3 plus 5 equals 3 plus 5. It's still true, right? 8 equals 3, or 8 equals 8 in the same way that 3 equals 3. We've been doing this all the time in algebra, at least I would hope you did. You, in theory, took the class. Theory. Subtraction property of equality says if we have an equal sign here, A equals B, left side equals right side, then we can subtract the same number from both sides and it will still be the same. Any number you want. It's all good. Any real number. Multiplication property of equality says, shocker, you can multiply both sides by the same number and it still be true. It's all good. We do this all the time, right? Cancel division. Here's where things get weird. Again, I'm going through my spiel. You're going to realize that some of this is scripted. Division property of equality. This is one I always screw up on when I'm writing it, right? Everything else is if this, then that, if this, then that, if this, then that. And when I make these notes permanently, with permanent marker, I always forget this a little bit and have to crumple the whole thing up and throw it away, which drives me insane. But I remembered it on this one. If A equals B and, not only that, but also, remember that ampersand, C does not equal 0. That's an equal sign with a slash through it. That's called does not equal sign, right? So C does not equal 0. We're allowed to divide by C to both sides and we're all good, right? We're not allowed to divide by 0 because if we do divide by 0, it breaks math. And that's what we call calculus. And it's super duper fun. It actually is. It actually is. Like real math is calculus. Everything else before that is just preparation for real math. Like all this stuff, you could be like, oh yeah, I don't really need it. I can just figure stuff out. Calculus is like, I could not figure that out unless I really studied this, which is fun. Reflexive property of equality is the real tough one. If A, then A equals A. Right? And this is not a difficult property because of how complex it is, because it's not complex, but because you're going to mix it up with a symmetric property all the time. It's A equals B, then B equals A, right? Symmetric, left to right, right to left. This one is like a mirror, reflexive, literally the same thing, okay? Reflection. We turn the page, we get to the transitive property of equality. This is a fun one. I don't remember if we talked about it or not, but I'm going to go through the spiel anyway. So check it out. Transitive property says if A equals B, and B equals C, so we got a C here on the left side, then A equals C. So it cuts out the middleman, right? We have A equaling B, B equaling C. We cut out the middleman, we get A equals C. So the idea here is that, here's a pen. If I'm touching the paper, that's A to B, and the paper's touching the pen, that's B to C, then I can say I'm touching the pen. Magic, right? So the example I always use is that I'm touching the floor, my feet are touching the floor, and the floor is touching you, which means you're touching me, and knock it off! Right? I know. So that's why I always teach like this.
That's even weirder.
Is it?
Yes.
What if I taught like this?
Oh.
Just like the whole time? All right, so let's talk about the substitution property of equality. If A equals B, then B can be substituted for A in any expression. Again, words are hard, math is easy. You've been doing this the whole time. It's the only thing you learned in algebra in theory is how to plug stuff in, right? So if x equals 5, I tell you that, then you know that 2x plus 1 is the same thing as 2 times 5 plus 1, right? Because x is 5. It is the same dumb thing, which means we can switch them out. Substitution means to switch out, right? Like every day I've been absent this week. Sorry, I apologize. Not my fault. I didn't decide to have a kid. So means you can switch them out because substitute and me are basically the same person, right? There's like no difference. You learn just as much from them as you do from me. All right, so after we... as we carry on, as Dr. Blackwell used to say, shout out to Dr. Blackwell, we have our postulates. This is the second to last page, I believe, in your proofs toolbox packet. Oh man, I love everybody that's got their like little notebooks. Oh man, so great. I wish they were in color. It'd be even cooler. Look like my giant notebook over there. All right, so segment addition postulate, SAP, if you will, SAP. It says that if A, B, and C are collinear, what does it mean to be collinear? On the same line. Co-linear. Co meaning the same, line, and linear meaning the same thing. And it says B has to be between A and C. Okay, so if we have 3 points on a line and B is the one that's in between, then we can say that AB plus BC equals AC. So again, the idea being that AB, this little bit right here, plus BC, this little bit right here, makes up the whole bit AC, right? You take a segment AC, you cut it somewhere, and you put the pieces back together, you're going to get AC again. Why is this true? It just is. There's no way to prove it. That's why it's a postulate. It's a leap of faith. We've built mathematics off this leap of faith, so hopefully it's true. Otherwise, everything comes crumbling down. The same logic with segments applies to angles. If D is in the interior, remember, interior means inside, inside means internal. Internal is like the voices I tend to ignore inside my head most of the time. Right? If D is in the interior of ABC, that's an angle. That's this guy right here. Here's ABC. Here's D being in the interior on the inside. Then measure of angle ABD, that's this guy, plus measure of angle CBD, haha, this guy, equals measure of ABC, the whole thing, right? So little angles add up to the whole angle that they are, a part of. Should not be blowing anybody's mind. But if it is, tell me to pause. Wonderful. Doing all right, Chloe? Wonderful. All right, so examples. Everybody loves examples. Okay, I'm going to walk you through them real quick, and then we're going to do some on our own. So here's an example. X plus 5 equals 9. You don't have this. X plus 5 equals 9. They give you that. Okay, so we have an equation, an A equals B situation, right? And they want you to prove that X is 4. So the way we do that is we take the thing we're given, and we manipulate it, move it around, do algebra to it, right? Things that are legal with equalities, things we mentioned before, and we make it look like that. So if we can use these steps, these rules, to make that into that, then we've proven that they are one and the same, right? That's what this means. You've been doing it in algebra the whole time. You would subtract 5 and you win, right? Make sure you do it to both sides, otherwise child abuse. We've talked about this. Algebra says if you do it to both sides, it's fine, and that's, keeps you safe in court. Trust me. So if we make it look like that, then we win. Kind of similar to how we did this stuff the other day. Actually, I could just use this, can't I? This thing, right? If we make that look like that, then we've proven that you can go from here to there using our rules that are allowed. The rules that are allowed here are these guys, right? So we go from there to there. That's the goal. So we start out with this. We say it's given to us, right? The part that you haven't done before in algebra is representing why you're allowed to do this, right? So we're given that. And our next step is to use the subtraction property of equality. Subtract a number from both sides, right? That's what allows us to do it, the subtraction property of equality, and that gets us X equals 4. And then we draw a swag box because we just proved something. Deuces. Questions on the swag box? Jenna?
Sometime can you teach us how to do that?
Sometime. Why not today? There's no time like the present.
I love making.
All right, so check it out. That is a square, so says I. And then you draw another square inside of it with one of the corners, right? And then, if you want to be super duper cool, you can even make a cube by connecting the corners. Amazing. You guys haven't learned how to do that ever?
No.
Okay. Where is your art education? All right, so we're going to keep this on the screen. So now we're here. Any questions on how to do that?
Oh, I like the colors.
Is there a 15-second delay on my class, or what's happening here? Okay, nope. Okay, fantastic, because I thought I got rid of it. Given 2x minus 3 equals 5. Well, we're going to use two properties of equality here. Which two properties do you think we're going to use? Wrong. Everybody says that because they see subtraction. Addition property of equality. What else are we going to use? Division property of equality. Nice job. We're going to prove that x equals 4. Isn't it nice to give you the answer? So the way we prove, again, is not to plug in x equals 4 into the equation, which would work, but again, we're trying to practice for when that's not as obvious. We need to make that look like this. So the way we do it is we write down what we're given, and we say that it's given, okay? And then we go to here, and we use the addition property of equality by adding 3 to both sides. We get 8 on the right side, and over here we get 2x. Again, we don't need to justify this step because it's just math. That's how it works. Eventually, we won't need to justify this either, because everybody will be on the same page. But right now this is new, so we have to point it out. Once our audience, the people we're trying to teach math to, understand this property, then we don't need to write it every single time. You guys understand this in theory because you took algebra, right? So we're just able to say therefore this. Okay? Then we're here, division property of quality. Do it to both sides. Remember, division is divorce. Divorce means everything gets divided, so everything does. This side, that side, and anything that's over there. Every term. And x equals 4, swag box. Questions, comments, concerns? Other than my mental stability. No? Okay. Another thing you can do instead of doing a swag box, usually it's just one box. I do two because swag, deuces. You could write QED, which is a Latin phrase. It stands for something. I don't remember what it is, but basically it means proof is in the pudding. I don't like that one. I think it's lame. I think the swag box is much cooler. You do you. Turning the page, last example. Spoilers. Here we are. What properties of equality were you going to use? Addition. We're going to add 6 to both sides, and we're also going to do what? Multiply by 5, right? Multiplication property of equality. So bam, there we go. We're given that. Bam, we do the addition property. Bam, we have this. Bam, we do multiplication property of equality. Bam, 45. You guys are ready for this. You're ready. You're born for this. All right, we've got 4 examples. If you want to get out some paper and do it on your own, I would highly encourage that. Graph paper's back there. Help yourself. It's free at the point of service, which should how anything that is an essential part of life should be, right? People charging for water? What are you talking about? It blows my mind we allow stuff like that. Like, you need that to survive. They could charge whatever they wanted, and it'd just be like, sucks to be you. But yet, it's normal. All right. So, think about what properties of equality we're going to use. Make sure you write down the problem and write given next to it. Again, what I would encourage you to do would be to do all the algebra first and then go back and write in why you were allowed to do it, right? What property of equality did you use? How did you get the starting statement? It was given to you, dingus. And when you get to the end, make sure you do your swag box so we know you're done. Again, it's not about what you do in life. It's about who you do it with. So work together if you have questions or if you just want to pal around. Have fun. Sure, whatever. I don't care. Yep. If you're ready, I'm ready. We had no song of the day, but I'll play some music anyway. Artist you've never heard of. No, I can't play Snoop Dogg yet because I had to find the clean version. But I will. I promise. I promise I will. I'm going to introduce you to a new artist that you've never heard of. Just recently released this single and album. Artist is Wyn Starks, Wynstarks. The album is Circles. The song is also Circles, which I think is a fun song because it's about circles. So he wrote a song about circles. Good music video, too. Little Motown opening.
Baby, I don't need much.
This probably will end up being a song of the day at some
'Cause
point.
when you're
Yeah, just
beside me, I feel like I have enough. When the world spins us around,
Looks great.
and the wind tries to move you, you know I'm holding you down. Oh, time it keeps moving so fast. Wish it would slow.
If you don't get x equals 6, then you should go back and check it because they're trying to ask you.
Before it passes
For now,
us by,
every proof we do in here
you
will be
should
doable.
know
So,
that it's you I wanna. It was you all of this time, and it's you that keeps running circles round my mind.
box and you just take them out.
Yeah, it's you I wanna dream about when I get out at night. Yeah, it's you.
Demonetize the YouTube. It's free advertising for my boy Wyn. Do it. It's not, no, it's not that they're taking it down. They're just not uploading. It's because the uploader wasn't working. I fixed it. There. That's not how that works. No, you definitely demonetize it. Although I don't monetize my channel. You're done with that one. Take a gander of this one. You're gonna need to check your boxes, aren't you? are hard, math is easy. We'll see in a second. Starks from the album Song Circles. Came out like a couple days ago. So, nerds. Feel good about the first one? Here's the first one. We did this one already?
Yeah,
We still have not gotten up to the point where we were last time. That's good. All right, so this is what you should have got. Now, could you have done division first? Sure, but you would have got 5 halves here and 17 halves there. As long as you're okay with adding and subtracting fractions, you can do that, right? PEMDAS is a lie. You don't have to do subtraction first. But it's convenient to do that because division is divorce, right? And we'd rather get the prenup. Remember Kanye? Right? So move stuff out of the house, get that 5 out of there, and then the only thing left to do is divorce. That way you only have to divide one thing instead of having to divide 2 things. Remember, when you do division, it happens to every term. So you divide the 5 and the 17. So if we only have 2 terms, it's a lot easier. Also, it helps that both those terms are even. That when we divide by 2, we get a nice number. That's just me. Number 2 says, given A, B, and C are collinear. What does it mean to be collinear? Same line. Very good. I keep asking this because there's some people who still don't know. AB equals x minus 5. BC is that. AC is that. Blah, blah, blah. We want to prove. I'm going to say this a couple times. BC is 47. We need to prove that BC is 47. We need to prove that BC is 47. So here's what those words look like in picture form. It's given to us. AB is that, BC is that, and they said AC was 5x minus 14. So the first thing we want to do, as you see here, is the segment addition postulate, which allows us to say that AB plus BC equals the whole thing, right? That's the magic there. So we need to start with that after we've written the given. Again, segment addition postulate doesn't tell us that x minus 5 plus 3x plus 5 plus, equals this, right? That'd be a very specific postulate, right? It would only be for these numbers and these letters. It says that the 2 segments that make up the big segment equal the big segment. So we need to write that first. The next step is going to be our substitution property. Remember, substitute means to switch out. And that's where we plug in the actual values. So step 1 is to write the segment addition postulate that says the segments add up to the big segment, right? Step 2 is to substitute that with their values. And now we have an algebra problem, which should feel very similar to what we've been doing, right? Get your x's together, terrible idea in real life, great idea in math. And when you do that, you're here. Again, therefore symbol is enough. And then from there, it should feel really familiar, right? This is like anything we've been doing the last couple times. So get on that on your own. Gonna need some subtraction property of equality, maybe addition depending on how you do it. Get it done. And then we'll move on to the next one. Easy peasy. Wonderful. It should feel that way. That was the goal. When we introduce new stuff, we try to give you stuff that you can latch onto and you're, aware of already. This is the stuff you should be aware of. This is the stuff that you haven't done yet. And hopefully the stuff you haven't done yet isn't too taxing upon you. So, somebody tell me what they did from here, because there's lots of ways to do it. That's the beauty of proof and the danger of proof. Plenty of ways to do it. What'd you do? Yeah, go ahead. Nice. Yeah, that seems to be what most people do, except for me. And what property of equality is that? Subtraction. SUBT prop, not SUBS, because otherwise that's substitution. Yes, ma'am? Yeah. You're allowed to do it, right? Do you break any rules? No, so it's okay, right? Again, there's lots of ways to do it. And I feel like you guys aren't comfortable with doing it different ways because you've been told PEMDAS, right? You have to do it this way, it's it, and that's all there is. So you never know if it's okay or not. Well, PEMDAS does not give us freedom under the law, but the properties of equality do. As long as you're obeying these rules, you're fine, right? The thing that trips you up usually is that when you multiply or divide, you don't do it to everything. You do it to both sides, but you forget to do it to every piece on every side, right? And as long as you do that, you'll be fine. Okay? Assuming you don't do something like add 14 and write a 13 on accident, right? Okay. So, yeah, some of you. We subtract 5x, and so that gets us over here, negative x, right? Negative 1x equals the negative 14x, or 14 that's here. And then what did you do next? Divide by negative 1. So we do division property of equality. I'm going to write this again. We divide both sides by negative 1. Or multiply by negative 1. Actually, either would work. So this would be an example of the division property of equality. Therefore, regular x, because negative divided by a negative is a positive, equals a negative divided by a negative is a positive 14. And we're done. We've proven what they wanted, so we do swag box, and we're good. Okay? That's one way of doing it. Here's how I did it. It's different than even Laney's method. What I did was I did subtraction property of equality and subtracted the 4x over. Now notice I'm not subtracting 4x from the negative 14, I just moved it over. It's going to go with the 5x, right? So don't be confused just because it's written next to that. It's going to go with the 5x, and we're going to get 1x on this side minus 14. And over here, what's 4x minus 4x? 0. And it's okay to get zeros. The reason I did this is because most people freak out when this happens, or they don't write anything. They get so confused, and it's because test anxiety, etc. And also 0 is a scary number. And we have this. And so now what am I going to do to get x on its own? I'm going to add 14 over, right? Same thing. A little more steps. Just wanted to show it because I know everybody's wondering if there's multiple ways to do it, and the answer is yes. That's the danger of proof. That's the danger of algebra if you don't follow PEMDAS, right? There's lots of ways to do it, which is kind of scary, but it's also kind of liberating. It makes sense. You can do it different ways. These are the real rules. PEMDAS is a lie. All right, so that's that on that. That's segment addition postulate. You need to start out with segment addition postulate and then work your way down to some algebra. The next one, oh, I blew it. I blew the magic trick, but no one was paying attention, so it's fine. So we're done, right? We're totally done. No, we're not. What did we forget? Yeah. That's right, because what did they want us to find? They wanted us to prove that, yes, BC, I believe, is 47, right? So we're not done. We found x. This is like most of you guys on your tests. You circle x because you're so used to it. But actually, they want us to prove that BC is 47. So the way we do this is we go back and write that BC equals 3x plus 5, because that's what they gave us, right? So in the middle of the problem, we go back to the givens, and then we plug in 14. And plugging in is substitution, right? So once we do that, there we are. Questions on that? Nah? Don't forget to do it. Okay, so next one, number 3, says prove that x is negative 32. We're not going to run through this. I'm not going to make you guys write it. We're just going to talk about it. So what properties of equality am I going to need to use? Addition at some point, and then what else? Multiplication at some point. Do it in any order you want, right? I can add 3 and get 21 over here, or 22, I should say, and then multiply by 2 and get 40 something, right? Did I just do something weird? I think I just did. Or we can multiply by 2 first. Doesn't matter. I feel like I've done something terrible here. All right, so now we add 3 to the negative 19. That's why. Should be a minus right here. How long has that gone unnoticed? If I add 3 now I get negative 16, double it, negative 32, right? Or you can double it first, right? If we double everything first, well, that becomes x, that becomes minus 6, that becomes minus 38, right? And then we can add the 3. It'll get us, not 30, math is hard. Why am I struggling with this? Add 6 and we get negative 32. All right, so we're here. I did the addition property first. Again, I just think that's easier than doing multiplication or division first. That's why we write PEMDAS the way we do. Then we're here. Then we times 2 to both sides. We get negative 32. Bam, done. All right, so let's get something a little more interesting. Number 4. Given D is in the interior of angle ABC. What does this sound like? What postulate? Given D is in the interior of angle ABC. Which one? Well, we have the segment addition postulate, the angle addition postulate, the AAP. Measure this guy is 100, measure this guy is that, measure that guy is that. Prove, I'm going to say it a couple times, that measure of angle ABD equals 50. Prove that measure of angle ABD equals 50. So here we are. Number 4, that's what it looks like. Okay? Yay, color. So we have green over here, red over there, and blue there. The whole thing is 100. The left side, ABD, is x over 2 plus 30, and this side is 3x minus 70. Angle addition postulate says that these two guys should add up to the blue, right? So I did that, and I did it in color. Isn't that fun? Isn't that fun? I think it's a lot easier. So we write that the angle measures add up to the big angle measure. We can't just skip to this step. Because to get there, we have to use substitution. Smell what I'm stepping in? Cool. Yeah, don't skip straight to this. And now that we have that, we just do algebra. So go get it. I know where you're going to get stuck, but that's okay. You don't see it yet. You may begin. Jericho, where are your glasses? Do you? Why are you squinting so much all the time? Aha! Mystery solved. You guys are all boring right now. You told me to amp it up a bit, and I did. Here you sit. The proverbial bumps on a log. Sticks in the mud. Poopers at the party. Do you think the word poop is funny because it's poop, or is it because it's just a funny word? Like, pretend that cars were called poop. Would it still be as funny? I think it would be. Just a silly word. You know another silly word? Stinky. And just feel it roll off your tongue. Stinky. Stank. Yeah. Jenna, how come you haven't coughed today? Are you better? Are you healed?
Sure.
Wonderful. We were going to have to perform an exorcism today. But
Why?
what do you mean, why? To exorcise your demons.
I mean, sure.
Okay. Get out the crucifix and smack you a couple times.
Get normalized.
All right, so I know where you got stuck.
Yeah.
Here's what happened.
Pretty sure.
You did this first, right? You got everything together. You got negative 40, because negative 70 plus 30 is negative 40, yes? And then you're like, what do I do with the 3x and x over 2? Well, you guys don't understand fractions because we never actually taught you how they work. So check it out. We're trying to add these two things together. It's like apples and oranges. The proverbial apples and oranges, if you will. They can't go together because this guy's talking in halves and this guy's talking in whole numbers, right? So here's how you need to think about it. Don't think about, I need to multiply the top and the bottom. We can do this in our heads, okay? You'll look like a genius. It's not that hard. How many halves are in the number 3? Pause. No. Terrible, awful question. Too hard. You can't do it. Let's be simple. How many halves are in the number 1? 2 halves. Everybody knows that. Duh. How many halves are in the number 2? 4. How many halves are in the number 3? 6 halves. So we have 6 halves plus 1 half. If I have 6 halves and Courtney has 1 half, how many halves do we have together? 7 halves of x. Isn't that dope? That makes sense, right? Now you can learn the trick to multiply the top and the bottom by 3. That's 3 over 1. To make the bottom 2, we have to multiply by 2. So we multiply the top and bottom by 2, I should say. We get 6 over 2. 6 over 2 is 6 halves. Plus 1 half is 7 halves. Now we're here. We add 40 to both sides. We get 140. Addition property of equality. Bam, we're here. And then I ran out of room. What am I going to do next? Multiply by 2 would be a good idea. You could divide by 7 as well. That would get rid of the 7. That's okay. You could also, at the same time, multiply by the reciprocal. Multiply by 2/7 to both sides. That gets rid of both of these guys at the same time. But I did it individually. I did it like this. I multiplied by 2, like Courtney said. And I get this. Then I divide by 7. Again, multiplication, division, same thing. Doesn't matter which way you do them, which order. I could have divided by 7 first and got 20. And then multiplied by 2 and got 40. Would have been the same thing. But we're not done. Because they don't care about what x equals. What they want to know is what does ABD equal. And we know ABD is x over 2 plus 30. Well, now we know that x is 40. We plug it in. We call that substitution. We divide by 2, we get 20, plus 30 is 50. 50. Swag box. How you feel? We just took a year off your life.
Well, that's sad.
Yeah. No one has seen The Princess Bride, I see. The 5-fingered man, 6-fingered man? Everybody has 5 fingers for the most part. Yes, what?
Can we put that back up there?
Why? You think it's homework? Like, what's the deal? Oh, Jenna. Jenna wants to know. Jenna, you did exercise your demons. What are we talking, like Pilates, Zumba? Yoga? All right, so that's that on that. Here's your homework, a little worky sheety for you. Now you're going to try it on your own. Some of these problems are going to look pretty similar. No one's caught on yet. Probably won't catch on now. Leanne's dance connection. Oh. Never liked the name Leanne. Anybody named Leanne in here has a real name Leanne? Darn. Try to find another way to make fun of you. Football! Woo! Your fault, Boo. For you?
Mr. Mac, I don't want it.
You don't want it?
I have an extra.
Oh, okay.
These are easy. She took it.
Courtney, you're so funny.
I know.
Play chance on word.
No.
See this.
All right, and that's it for today. On Monday, we need to catch up a little bit because out of all my geometry classes, you guys are a day behind. It happened the other day. When we tried to go through this the first time, we got majorly distracted by the warm-up. That was a toughie for you guys.